Implementing security applications. Now, we've already talked several times about different types of mitigation already in this CBT Nugget series. And we're going to get further into mitigation techniques here, especially when it gets into the network solutions like network intrusion detection, network intrusion prevention systems, firewalls, and the like. But before we jump into the enterprise-wide or the small to medium-sized business mitigation techniques, let's kind of stay on the client side, on the individual user workstation or the individual user laptop or mobile device. We want to look at several things here to kind of lock down and tighten up security, implementing security applications on the end user workstation. In this nugget on implementing security applications, we're going to look at several key areas, several requirements of individual security apps on the workstation client side that are covered on the Security Plus exam. We're going to look at host-based intrusion detection and intrusion prevention systems. We'll talk about personal firewalls, antivirus software, anti-spam applications, and anti-spyware and pop-up blockers. Now, before I even differentiate between host-based and network-based IDS and IPS, let's go ahead and define what intrusion detection systems and intrusion prevention systems are. These are going to work together in most enterprise organizations to form that integral piece of robust network defense in depth. Now, we're really focusing here on the host-based aspect of it. And this means installed on individual servers and workstations and laptops and mobile devices. But we want to understand first of all how IDS and IPS works together to provide our network security solutions. Now, what an intrusion detection system does is it's going to capture packets on the network or packets that are going into a workstation in real time. It's going to process them. It's going to respond to threats. But remember, it's going to be working on copies of data traffic. In other words, it's pulling data from, let's say, a switch port or a network interface port coming into a workstation or a laptop to detect suspicious activity based on existing signatures. And it really relies on how recent your signature database is to how effective it is. So an IDS is going to analyze copies of the data. It won't affect throughput because it's not an inline solution. You're actually sending copies of your data to a separate device called a sensor. Now, a sensor can be software installed or it can be an actual physical device. So the net result is an IDS is going to allow some malicious traffic to pass before it can even respond to the network. So in a way, an IDS is a little bit more reactive than an IPS, which would be a little bit more proactive. Now, why do we call an IPS or an intrusion prevention system proactive? Well, because it's an inline solution. It's in the line of traffic, and it's monitoring layer 2 through layer 7 of the OSI model. Now, let me just remind you real quick about these 7 layers of the OSI model. Take a little sidebar here. Now, memorizing the OSI model isn't listed as one of the objectives on the Security Plus exam, but you should know it. And I'm going to go ahead and give you a little bit of homework here. You want to probably go and do a little research on this. Layer 7 of the model is the application layer. That's where applications like DNS and SMTP and other applications like that operate. Then we have layer 6, which is the, I started to write session, which is the presentation layer. Not a whole lot goes on here. A little bit of translation into ASCII text, maybe some encryption perhaps, presentation layer. Then we have the session layer. This is what allows us to have, let's say, on our operating system functioning several browsers open at the same time, maybe an FTP session, doing some file transfer as long as with our instant messaging going in the background, maybe a telnet session open, and maybe a remote desktop session to a PC. All of these things working together in the sessions, kind of keeping them separated for the operating system. Layer 4 is the transport layer, and this is where the TCP and UDP protocols operate. TCP is reliable, connection-oriented. UDP is unreliable and connection-less. Layer 3 is the network layer. And that's where networking protocols, or let's say routed protocols like TCP/IP and IPsec and AppleTalk work, and routing protocols like RIP version 2, OSPF, EIGRP, ISIS, things like that. We have layer 2, which is the data link layer. And this is where your network interface cards operate, and other framing protocols like frame relay, for example. And then layer 1, the physical. And this is where everything gets turned into zeros and ones, and you've got your kind of your encoding for your wired media and your wireless media. So you want to memorize these 7 layers. You might want to use a mnemonic to do that. For example, I don't know, please do not touch Steve's pet alligator, okay? Or start from the top. All people seem to need data processing, or maybe all people studying this need drastic psychotherapy. That's a funny one. Programmers do not throw sausage pizza away. Whatever you need to do to memorize that. I don't think you're going to be tested on that on the exam. It's not an objective, but everybody who's in networking should know this. We're dealing with security here, so it's probably not going to show up on this exam. You'd see it on a Network Plus exam, but so many things that we're dealing with, for example, as you talk about intrusion detection systems and intrusion prevention systems, IPS can operate all the way from the data link layer all the way up to the application layer. So they can, IPS can really do deep packet inspection and look at all different types of traffic all the way deep into the data. So that's where this IPS dealing with layer 2 through layer 7 comes in. And we're back. So generally speaking, intrusion prevention systems operate in line as they monitor deep packet inspection from the data link layer 2 all the way up to application layer 7. It has to be able to handle whatever network traffic you have. Why? Well, because it's in line, so all the traffic's flowing. So if you're going to, let's say, get a Cisco IPS sensor device, it has to be able to handle whatever bandwidth you can pump through it. Typically, you're going to place those IPS sensor devices maybe at the edge of your network, the perimeter of your network as you get through the firewall, maybe between your core switches and your data center or your server farm, maybe between the core switches and your distribution layer switches that go to different buildings or different floors of your office building or different remote areas of your network or your campus. So IPS, there's a strategy for placing those, but they have to be able to handle the network traffic. And IPS, when tuned properly, so let me jot that down here, when tuned properly, will stop malicious traffic from entering your networks or your systems in the case of a host-based IDS or a host-based IPS solution. So, just generally speaking, the key way to differentiate an IDS from an IPS is that IPS will respond immediately and does not allow malicious traffic to pass, where an IDS will allow malicious traffic to pass before it can respond. It's reactive. IDS and IPS technologies are typically deployed as sensor devices. They could be sensor software or sensor hardware. It could be a router configured with sensor software. It could be a dedicated appliance that provides IDS or IPS services. Or it could be a module that's installed in some type of modular device, like a security appliance or a switch or a router or a multi-layer switch. Both of these technologies are going to use signatures. Signatures are defined patterns of misuse in network traffic. Understanding all the ins and outs of the IDS and IPS technology is well beyond the scope of this Security Plus series, but let me draw you a diagram here that kind of shows you just kind of the operational differences between IDS and IPS. Okay, I'm no artist, but I play one on TV. And as you can see on the left-hand side, I've got my IDS. On my right-hand side, my IPS. This is the untrusted network. Okay, this is the, I'm out of control. This is the untrusted network here. And so we have our malicious user out here somewhere outside coming into our perimeter routers, and everything stays the same, okay, coming into our network at our perimeter with IDS and IPS up until that point. Now what happens over here on the left-hand side is this is a router, and this is coming into a switch. Now, coming off of one of my switch ports is the IDS sensor, or it could be some other device with sensor software or a modular sensor device. Plugged into that sensor, this is my management station. So I'll just put MS here. This is where I sit at, that I access my syslog server, all my other monitoring and management applications on my network. And this is the sensor. And it's copying packets from this switch to the sensor device in a reactive way. Then traffic goes to the router. This is the target. This laptop right here is the target host of my nefarious user out here. And as traffic comes through the perimeter router into this switch, and again, we may have firewall solutions, but of course we're assuming traffic's getting through the firewall, our IDS device. So here's what happens with IDS. Attack gets launched on the network. We've got a sensor deployed over here in what's called IDS mode, or it's an IDS device. We've got the switch sending copies of all the packets to the sensor, and the switch is configured in what we call promiscuous mode, all traffic. The IDS is going to analyze the device. Again, this target device will experience this malicious attack because this is reactive. The management station and the admin here has to react to the information sent to him as alerts and triggers and logs, other information to that particular security technician. The IDS sensor is using a signature to match the malicious traffic. Will ultimately send a command to the switch to deny the malicious traffic, but again, some of that stuff's already gotten through. The IDS, as I mentioned, will also send an alarm or an alert to the management station for other logging and management purposes. Now, let's go over to the IPS solution. The attack gets launched against our network, comes through the perimeter router, passes through the firewall, but all the traffic goes right through this IPS sensor, which is sitting in line. So the IPS sensor analyzes these packets as soon as it comes into its inbound interface. The IPS sensor is also using signatures, hopefully up-to-date signatures, matching the malicious traffic to those signatures, and then hopefully the attack is stopped immediately there. And what it actually does, it sends it to a thing called a bit bucket. In other words, it's just a little black hole on the sensor device. So before the actual traffic can get through, the IPS sensor can also send an alarm or an alert to this management station, but here's our target laptop, and hopefully the malicious traffic never gets there. That's IDS versus IPS. Now that you understand the differences, and we'll revisit the network version of this later on in this Nugget series, but let's talk about host-based IDS and a host-based IPS, because this is really where we get these systems, these sensors installed on our end user. In other words, in this case, we would install some software on these target laptops instead of here at sensors. These would be host-based, or maybe on a departmental server, and the solutions that we get here. And then again, this is what provides us with what we call defense in depth, or otherwise known as a layered solution. A layered solution. Now you might be saying, why do I need host-based IPS? Well, maybe you've already got antivirus software on your PC or your workstation, your laptop. You've got a personal firewall. Here's the deal. It's not enough. And as I show you how HIPS works, you'll see what a powerful solution it can be, especially when you're dealing with an enterprise-wide solution on all of your devices throughout a network tied into some centralized system or server. Now there's a lot of different products out there, and this Security Plus exam by CompTIA is vendor neutral, okay? It's not vendor specific. So I'm not really going to be selling you on any particular vendors, but understand I'm a Cisco professional, and I've got several Cisco certifications. That's my area of expertise. So I'm going to kind of focus on my understanding of these products from a Cisco standpoint, even though it's not important for you to understand this yourself. Again, Security Plus is vendor neutral. But let's look at some of the characteristics here. I'll list these out of a host-based IPS system. I'm focusing on intrusion prevention systems because IDS systems are actually kind of legacy solutions, especially from a host-based standpoint. It's all about intrusion prevention, okay? Just the name itself, intrusion detection versus intrusion prevention, which would you rather have? I mean, think about it. Do you want a device that tells you when your car is on fire, or do you want a device that prevents your car from catching on fire? There you go. Enough said. Let's look at some features here. Host-based IPS is actually software sensors installed on individual hosts, workstations, laptops, departmental servers. It's not a hardware solution. The purpose of HIPS is to audit log files, the individual file system like NTFS, for example, or FAT32, and resources, memory, processor, other resources on that end-user workstation, including the configuration database, let's say on a Linux system, or the registry on a Windows system. It provides individual host detection and prevention. So host-based IPS actually combines HIDS and HIPS, okay? It can also be centrally managed, so it could be a standalone solution on a workstation, or it could be tied into, let's say, a Cisco overall MARS management solution. It could be tied into network admission control, or from Cisco, or NAP from Microsoft. So you can centrally manage all of your individual hosts, you can update them, and you can have sensors going to a central location as well. So it's not just a standalone solution. It can be integrated and operating through the enterprise in a centralized fashion. It stops attacks in real time using signature databases and what we call anomaly detection. So it kind of gets a baseline of normal activity in anything anomalous in the log files, file systems, resources, registry. It can trigger a proactive reaction on the system. As a matter of fact, some HIPS solutions are so comprehensive they can actually combine the best features of antivirus solutions, antivirus, anti-adware, anti-spyware, with a personal firewall solution and an application firewall doing deep application inspection, all in one solution. As a matter of fact, Cisco's CSA, or Cisco Security Agent, is just one of those products that can provide these solutions. How does a HIPS system operate? Let's take a look. Okay, let's do some more Fred Flintstone School of Art here. Here is our application, and then we've got, sitting in between, here's our host-based IPS solution from some reputable vendor. And then what we have here, underneath all of this in the operating system, is the OS kernel, or the core files of the operating system, including the system registry. You can't really read that. Let me just write this here. Kernel. The core operating system, which includes configuration files, system files, the registry, everything that interfaces with all of the hardware and other components such as memory processes, network interface processes, processor processes, and the like. So we'll get an arrow going here and an arrow going here. So an application is going to make a call to system resources, but HIPS is going to step in and it's going to check this call and it's going to compare it against a policy. And typically what you do is you create these policy groups, and a policy group is just a bunch of settings, and then you take your different types of hosts and you place those into those groups. For example, if you've got a bunch of laptops running Windows XP and a lot of workstations running Linux, and you've got some departmental servers, you can place all of those different devices into different groups and apply your own policy to it. So the HIPS is going to check this application call for system resources against an existing policy. Then the request will be permitted or denied based on the policy. So what HIPS really does is it intercepts operating system and application calls. And these policy rules are going to control and manage the application stacks and the network stacks. Processor controls built into HIPS will limit buffer overflow attacks, any changes to the registry or configuration files, any writes to system files or system directories, and launching of installation programs. HIPS is not just signature-based, it's also behavior-based. So it learns and it can respond to anomalous behavior. Now, that all sounds great, but realize that HIPS is not going to provide a complete overall picture of your network. Remember, it only examines data and processes at the local host level. You're going to install these on your end user hosts and other hosts. So it has a hard time, even in an enterprise organization, building an accurate network picture. That's why we have to combine HIPS with what we're going to look at a little bit later on in this nugget, network intrusion prevention systems. Okay? The other thing is HIPS has to support multiple operating systems and multiple versions or iterations of that operating system. So this means a lot of updating, a lot of support, a lot of technical support, making sure that all the different flavors of Linux, Sun Solaris, all the different versions of Windows, Macintosh, all the client end user operating systems, to make sure that you have full featured functionality and interoperability with that host-based IPS system that you're using. Okay, that's HIPS. Let's move on now and talk about something that I've already alluded to, and that's personal firewalls installed on those end user hosts and workstations. Maybe you've got one. I want to get away from the whiteboard for a little bit and get into some more real-world application here. If you look at personal firewalls, now there's a lot of these out there. There's Zone Alarm, Cisco's HIPS falls in that category, Cisco Security Agent. Maybe you've got McAfee. You can see here when I got this Vista computer, it offered me the ability to go ahead and subscribe to Norton Protection Center, which is a security suite. McAfee has its own security suite. I went ahead, since this is a Microsoft product, I went ahead and went with Microsoft's Live OneCare. And again, the bottom line is with these personal firewalls, you want to have the ability to have updating from the vendor on a weekly or daily basis to the internet. So you can see here, it says my status is fair because I haven't configured the backup on this thing yet, backup and restore, but you can see it's got virus and spyware monitoring, definitions, scanning, phishing filters that I mentioned earlier in a previous Nugget movie, the phishing filter in IE7, which is turned on, so it's updating that and learning. I've also got a firewall. So let's go ahead and change my settings. Of course, needs my permission, and we'll get this little dialog box here, Windows Live OneCare settings, and you know, Windows Live OneCare is a great example of a personal firewall, and it's really excellent because it works quite well. It's a Microsoft product working with a Microsoft operating system. I'm going to go to click on the Configure Firewall, and you can see some other settings that are showing up down here. Notify me when the firewall blocks an application. I'll get a dialog box that pops up there. That's something I have turned on automatically. You can see we've got these kind of zones here that are kind of, you know, they're pre-configured firewall settings. I want to go farther than that, though. I'm going to get into the advanced settings and show you 3 areas here that personal firewalls operate on. First of all, we can go in here, and we usually, on all of these, they're very similar. They do an inventory of the applications and services that are installed on your system, and you have the ability to go in here and say, you know what, I may want to go and disallow or block. This is an end user, I'm going to get rid of the blocking the poker stuff here. I don't really want to do that. I like to play poker, but if you've got certain programs like games that you've downloaded off the internet that may be causing problems, you can block. So, and of course, there's always the ability to go and learn more about blocking, or you can edit certain features by going to the edit option here. And that's applications and programs allowing and blocking. I can also go and choose ports and protocols, where I really get to go in here and I can either look at the existing ports and protocols and realize all of these have TCP and UDP numbers assigned to them. It's not important, but you can see I can allow certain ports and protocols. ICMP outbound, ICMP version 6 inbound, and you can see, of course, 1CARE is being allowed as well. And you can see what you can go in here and ports and protocols. You can also add to that with the add button. You can put in a name for it. You can choose TCP, UDP, or both. For example, DNS operates on both TCP and UDP. Choose your port range, and you can block. Why is this important? Because, well, you know, a lot of programs like peer-to-peer file sharing programs use a wide variety of port ranges. Other attacks, denial of service attacks. So we can really get granular with controlling the ports and protocols in our personal firewall. We can also go in and monitor network connections. Right now I've only got one network connection, but I may have somebody, let's say, using my particular laptop. Maybe they've got an ad hoc wireless connection to it, and they're using my internet. I might want to come in here and see if somebody's got a connection coming through my firewall. I might want to go ahead and disconnect that. So these are the three main areas of a personal firewall. You can manage programs that you allow and you block, ports and protocols that you allow, or you can customize this and add and get very granular, or network connections. You also want to make sure that your personal firewall is updated as much as possible with the vendor. And this is usually an annual subscription, just like Windows Live 1CARE. Windows Live 1CARE allows me to pay an annual subscription and install this on 3 personal computers. So I like that aspect of it. You can also do the same similar thing with Symantec, McAfee, and other products out there, personal firewalls. And they'll show up down here in your system tray. As you can see, if I were going to go ahead and get launch Norton Protection Center, I could do that as well. But I'm happy just to use Windows Live 1CARE. Okay, I'm going to return back to my Windows Live 1CARE. We're going to kind of talk about antivirus and anti-spyware, anti-spam, all right here, kind of in one fell swoop as you get back into the interface here. Now, anti-spyware software has become a huge element. It's actually a best practice for Microsoft Windows desktop computers, as well as antivirus. Of course, antivirus and anti-worm really was around first, and then spyware became so prevalent with software surreptitiously installed on the computer that we had to do something. And so Microsoft has included here kind of a virus and spyware monitoring tool. Now I can see here that my last scan was done at 6:46, and I went ahead and I made sure that this ran this morning. But I can always go in here and I can do a manual quick scan looking for harmful software. Harmful software takes about 10 minutes. A complete scan is going to look at the whole computer, including any external drives, or I can customize my scan here and choose what areas of my system I want to scan, just like kind of a backup program. I can also come in here and pick and choose areas of my system, so I can go on a folder by folder basis or a system files by system directory basis and take a look at areas that I want to go ahead and scan. And so I've got a lot of granularity here with this Windows Live 1CARE product, very similar to other products that you might see out there by companies like McAfee and Symantec, among others. Now, I'm not going to go ahead and run a scan right now. I ran one this morning at 6:46 a.m. But I am going to go to the change settings area here. And when I do this, I need to click on continue. This is Vista. I'm going to move down here to the tab that says viruses and spyware, and I can see areas. For example, I've got my virus and spyware monitoring turned on. So this is an always-on situation. I've also got a DSL connection, so I'm always connected to the internet. So I've got access to Microsoft's website, downloading signature updates on a regular basis. I can also choose to look for virus-like behavior. It may not be a signature, but it has the same type of characteristics of a virus. If I want to turn it off, I can do that as well. Not recommended. I can schedule my scans to scan daily, any day of the week, maybe off-peak hours if I want to do it that way. As malware is found and discovered on my computer, it can be sent to a quarantine area where I can basically operate off of it, delete it, and restore it here. If it's suspicious software, it may not be a virus. It may find a program that I installed and consider it a virus, put it here, and I can restore it if I wanted to. I can also exclude certain things, and you can notice that Windows Live OneCare actually excludes itself, its database, from this antivirus information, because its database is going to have information that looks like a virus. If I need more information on viruses and spyware protection, I've got hypertext links that take me to the World Wide Web, pop me up here to the Internet, and I can find out more information about the current virus definition file, definitions of viruses, spyware, and virus-like behavior. I can also find out more about phishing that we've alluded to, and this just tells you that phishing is the use of deceptive and fraudulent websites. We've explained that. OneCare gives me the ability to install IE7 and turn on a phishing filter, which is a great tool for your email. I'm going to pop out of here. Notice at the bottom here under Advanced Settings, OneCare is going to automatically take action against high or severe, but I can also go one step further and say, you know what, even if you rate it moderate, I want to go ahead and take automatic actions against moderate threats as well. Or I can disable that if I want to. So lots of granularity, lots of ability to control viruses and spyware, which pretty much run hand in hand now, especially as far as your security suites are concerned. Now I'm going to cancel out over here. I'm going to go to Internet Explorer. I'm using version 7.0. Comes up to a blank page automatically. If I go to the Tools area here, I can go and I can see my pop-up blocker, where I can turn off my pop-up blocker, or I can configure pop-up blocker settings. On a pop-up blocker, it usually gives me a little taskbar that pops up here that gives me the ability to see pop-ups on an individual basis. I can see here, I can go and I can say, look, there's websites that I go to on a regular basis, maybe my corporate website, my banking website, poker websites, or online investments. I want to go ahead and allow those pop-ups on those sites. Some sites that you need to access on a regular basis, you don't get functionality out of them unless you allow pop-ups. For example, if you're doing online training through some company with video or audio streaming, you have to allow pop-ups often to get that online streaming training. And I can also say, play a sound when a pop-up is blocked or not, and show the information bar. And that's the bar I was talking about, the kind of the taskbar information bar up there. I have this turned on so I see this every time a pop-up is blocked, so I can go and just click on that to allow the pop-up, or I can go and set different levels, low, medium, and high, of pop-up activity. I'm going to close out of there. Another area on the Tools menu is that phishing filter. And the phishing filter, again, is what I told you is installed in IE7. It's a fantastic feature. You've got phishing filter settings, and when I do this, this pretty much takes me to my Internet Options Advanced tab. And not the Security tab, but the Advanced tab. So if you're looking for your phishing settings, that's where it's at, the Advanced tab in Internet Options. And you can see here in this area, I can scroll down and I can find basically my phishing settings. Down here at the bottom, I can see my phishing filter, which can be disabled. I can turn off automatic website checking or turn on automatic website checking. I have the most aggressive feature, turning on automatic website checking. So that's my phishing filter, and this is a fantastic tool. It's really necessary now in those security suites to have that phishing filter. Microsoft IE7 offers that. Okay, now I'm in Microsoft Windows Vista's version of Outlook Express. It's called Windows Mail. This is a good, solid emails client to look at here. It's also relatively new. So I'm going to go up to the Tools area here. You can see I've got a junk email folder. We don't call it spam. We call it junk email in the Microsoft vernacular. So I'm going to go up here to Tools in the main menu and go to my junk email options. Several areas here I want to focus on. And if we look at this options area, you can see we can choose different levels of junk email protection. Right now I've got a pretty low level because I don't get much email on this system, but we can say no automatic filtering, most of the obvious junk mail, most junk mail is caught, check your junk email folder often because some stuff might slip through, or I can say, you know what, I'm going to create a safe senders list. I'm only going to get mail from people or domains on my safe senders list. I can also say, you know what, permanently delete the suspected junk email instead of moving it to the junk email folder. So if I have a setting like this, high and permanently delete, I'm probably going to lose some valid email there. So I might want to choose this option and leave that open because I get a lot of corporate email. I want to make sure I don't do that. Now here's the safe list, and the safe senders list is here. I can just simply go add individual users or an entire domain if I want to. For example, cbtnuggets.com I might add in there. I can also say, as I've got here, trust email from my Windows contacts so they're automatically trusted. And I can say, you know what, if I add somebody, I can also say if I email somebody manually by creating a mail up here, go ahead and add them to the safe senders list. I can also choose block senders, people I want to make sure I always block from. International. I don't know about you, but I get a lot of email that is from other countries and uses other character sets, and I'm really sick of it. So I can go and say, you know what, I'm going to go to the block top level domain list. I may not expect email from any foreign country, so I'll just select all and click on OK. I can also say I'm going to block certain types of character sets, block encoding. So if you get email with different kinds of character sets in there and you know that you shouldn't be getting those, I can just select all and click on OK. So those are two great features they've added in Windows Mail. Of course, if you're using a full-blown client like Microsoft Outlook, you're going to have some more options. And here's that phishing tab where I can access this to make sure I click on this and say, you know what, I want to go ahead and have phishing protection that's provided to me by IE7 combined with Windows Mail, formerly known as Outlook Express. So there we go. That's my protection for spam, or as we call it in the Microsoft world, junk email. Alrighty, in this CBT Nugget, we looked at implementing security applications specifically on the client side or the end user workstation or laptop. We first looked at the concepts of intrusion detection and intrusion prevention, the general concepts, and then we moved that over into the host-based world with HIDs and HIPs. We also looked at personal firewalls. In my case, we looked at the Windows Live OneCare solution. That's an excellent solution to use with your Microsoft operating system. Looked at and talked about antivirus, anti-spam, anti-spyware, which kind of goes hand in hand with antivirus now in your security suites. Also revisited the concept of phishing protection and looked at pop-up blockers. I hope this CBT Nugget has been informative for you. I want to thank you for viewing. We'll see you next time.